Imagine a night sky vast and full of stars but with a mysterious void, an area seemingly empty. Welcome to the zone of avoidance. This intriguing region of the cosmos is not devoid of celestial bodies, but rather a space obscured by our very own galaxy, the Milky Way. Picture this. We are standing in the midst of a cosmic forest, and the dense foliage of our galactic home hinders us from seeing what lies beyond. This obstruction is primarily due to interstellar dust, tiny particles that float in the space between stars. They scatter and absorb light, making it difficult for astronomers to observe distant galaxies that lie within this zone. It's akin to trying to peer through a foggy window, where the fog is the dust and gas of our galaxy. So, we are faced with a cosmic blind spot, a celestial conundrum, the zone of avoidance. Now, you might be thinking, why is the Milky Way causing such a problem? Well, imagine trying to peer through a dense fog with your naked eye. You'd only be able to make out vague shapes, if anything at all. That's essentially what's happening when we try to observe the zone of avoidance. Our Milky Way is a bustling hub of stellar activity, filled with clouds of dust and gas, along with countless stars. All these elements come together to form a kind of cosmic fog that obscures our view. This makes it quite a challenge for astronomers to penetrate this galactic veil and observe what lies beyond. It's a bit like trying to see the view from a window covered in dirt and grime. No matter how much you squint or adjust your angle, the scene outside remains blurred and indistinct. The Milky Way, beautiful as it is, stands as an imposing veil between us and the zone of avoidance. Scene script. How then can we see through this cosmic dust and gas? Enter radio and infrared astronomy. Imagine yourself trying to gaze at a distant landscape through a dense fog. It's near impossible, right? Our situation is similar when trying to peer through the dusty veil of the Milky Way to observe the zone of avoidance. But do not fret, we do have a way to navigate this cosmic fog. Harnessing the power of radio and infrared astronomy, we can penetrate the dusty shroud of our galaxy. These are not the types of waves you'd catch on your beach vacation, but rather waves of light that our eyes can't see, but our instruments can. Radio waves, with their long wavelengths, have the ability to cut through the dust and gas, like a hot knife through butter. These waves can travel great distances without being absorbed, providing us a clear view of the obscured regions of the universe. Infrared astronomy, on the other hand, is a bit like having night vision goggles. Our galaxy is full of stellar nurseries, areas where new stars are born, and they glow brightly in infrared. By tuning our telescopes to this wavelength, we can see the warm glow of these cosmic nurseries, even through the dust. With these tools, astronomers can pierce the veil, illuminating the obscured mysteries of the zone of avoidance. Beyond the dust and gas, what lies in the zone of avoidance? A gravitational anomaly known as the Great Attractor. As we venture further into the zone of avoidance, we encounter a phenomenon that baffles even the brightest minds of our time. This is no ordinary celestial body or a simple collection of stars. Instead, it's an area of space that exerts a gravitational force so strong, it's pulling entire galaxies towards it. This is the Great Attractor. The Great Attractor isn't just a solitary entity, it's a gravitational anomaly located at the center of the Laniakea supercluster, which is home to our Milky Way and about 100,000 other galaxies. However, what makes it so intriguing is not its size or its strength, but the mystery that surrounds it. Despite its colossal gravitational influence, we are still unsure of what it actually is. Is it a massive black hole, a dense cluster of galaxies, or perhaps something we've yet to discover? The truth remains elusive. Even with our most advanced telescopes, the Great Attractor is hidden from our view by the dust and gas in the Milky Way's disk. This shroud of dust and gas in our own galaxy makes it one of the hardest places in the universe to observe. Yet, despite these challenges, our curiosity remains undeterred. The Great Attractor continues to pull us in, not just physically, but intellectually and emotionally as well. It's a reminder that the universe is vast, mysterious, and full of wonders waiting to be discovered. The Great Attractor, a cosmic mystery, waits hidden in the zone of avoidance, pulling us ever closer to its enigmatic presence.